Okay, today's lesson we're looking at parallel lines and proportional parts. How does a line that is parallel to one side of a triangle divide the two sides that it intersects? We're going to look at that. There's a couple different things that we're going to look at. We're first going to look at a proof. But before we do that, let's talk about the triangle proportionality theorem. It says that if a line is parallel to one side of a triangle, intersects, if a line parallel to one side of a triangle intersects the other two sides, then it divides those sides into segments of proportional length. And what that means is, here we have a picture of it. I have a line that is parallel. That means these segments are going to be proportional. Basically, we can say that A over E over B is going to be proportional to A over F over C. Okay, and below we've got a proof for that. This proof you don't have to memorize, remember. We're just going to talk about how we can prove that's going to happen. So we're going to prove that these similar triangles, since EF and BC are parallel, we're right here looking at this. Since EF and BC are parallel, you can conclude that 1 and 2 are congruent, and 3. So 1 and 2. So this angle is congruent to this angle. 3 is congruent to 4. Because since those lines are parallel, we have corresponding angles. So they are similar. These two triangles are similar, and when I say two triangles, I mean the larger one and then the smaller one that's formed by that parallel line. The two angles, or the two triangles, are similar because we have just proven angle-angle similarity. Two pairs of angles are congruent, therefore the triangles are similar. So, we've proven that they're similar. I'll try and keep the picture of the triangle in there so we can reference that. Use the facts that corresponding sides of similar triangles are proportional. So AB over AE, so when we're talking about that, we're talking about, let me erase, it won't let me. AB, which is this side, over AE, which is the short side of the triangle, is equal to AC over AF, AF being the short side. Okay, that's nothing new. We've seen that before. And that's because corresponding sides are proportional. Then what happened here is they divided it up. Instead of writing AB, they wrote AE plus EB. They basically broke it up into two segments. So we're going to say that AF plus FC, which is the same as AC, and then we're going to put that over AF because of the segment addition postulate. We took the one long segment and divided it up into two smaller segments. Okay, now they took that and they broke it down, and when I say they broke it down, where did they get this 1? Well, they split that up into, and I'll write it over here on the left, A over E over A over E plus E over B over A over E. So do you see where they got the 1? They basically broke that one fraction up into two fractions, and the A over E over A over E equals 1. We're going to do the same thing with the A over F. A over F over A over F is 1. Plus, we still have FC over A over F. And we can do that because of this. We can break it up into two fractions. Now, you'll notice that they got rid of the 1s. So if I subtract the 1s, we're left with FC over AF. And we can do that because of the subtraction property. And then we take the reciprocal of both sides. A over E is now they're flipped, so we can say A over F over C. And we can see that that is exactly what we were talking about. So like I said, not anything that you have to memorize. That's just a proof showing you why we come to that conclusion. So, since I know that, now, we don't have to prove any of it. It's a given to us now since we've already proved it. We have two triangles here. It says that PT is 7.5. So this segment is 7.5. TQ is 3. And SR is 2.5. Find PS. Well, remember, they're proportional. This segment and this segment, so x over 2.5 is proportional to 7.5 over 3. Cross multiply, divide by 3, and x equals 6.25. Simple enough. Okay, the converse of that says that if a line intersects two sides of a triangle and separates the sides into proportional parts, proportional corresponding segments, then the line is parallel. Which means if we don't know if the two lines are parallel, we can check that by seeing if those parts are proportional. If they're proportional, then the lines are parallel. For instance, look at this example. It doesn't say that the two lines are parallel. So, but they do give us some segment lengths. EH is 3, HF is 9, DG is a third of GF. That means that GF is 3 times as big as DG. So whatever DG is, GF is 3 times as big. So we can write a ratio, so we'll put x over 3x, and if that ratio is equal to 3 over 9, then those two lines are parallel. So I'll cross multiply, I get 9x equals 9x. They're equal to each other, therefore my answer is yes to that question. Are those two segments parallel, these? Yes, because these two sides are proportional. Okay, now a student says that UV must be parallel to ST. Do you agree or not? In this picture right here. Well, let's see. We have congruent sides here. If they're congruent, if this is x, this has to also be x, doesn't it? Likewise, on this other side, if this is y, this has to be y. So if we wrote those as a ratio, we would say x over x, because that's how we would do this, is equal to y over y. Basically, that simplifies to 1 equals 1. Are they equal to each other? Yes, therefore, those lines must be parallel. Okay, midsegment of a triangle. This is another statement. A segment with endpoints that are midpoints of two sides of the triangle. Every triangle has 3 midsegments. So the midsegments in this case are RP, PQ, and RQ. And the triangle midsegment theorem says that a midsegment of a triangle is parallel. That's the definition of a midsegment to one side of a triangle, and its length is half the length of that side. So looking at this bottom one, we see that if we call JK a midsegment, we say that it's parallel. It splits those segments into half, and it's half the length. So whatever FG is, JK is half of FG. Okay, so let's see how some of this applies. If we have this triangle, it says to find x, well, it doesn't say which ones. Well, I'll tell you which ones. Find xz, find st, and find the measure of angle RYX. Well, look at XZ. It's right here. It is a midsegment. That means it's half of RT. Look at RT. It's 13. So XZ is half of 13, which is 6.5. Okay. B says to find ST. Well, look at that. XY is the midsegment, and it's 7. ST is that side. 7 is the midsegment, is half of ST, so ST has to be 14. Now remember that midsegments are also parallel, and this next question has us looking for RYX, which is this angle right here. If we're looking for that angle, remember that this line is parallel to this line, so what we have right here are alternate interior angles, and they're congruent to each other. So that measure is the same as 124 degrees. Okay, and proportional parts of parallel lines. If 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally, which means that AB and BC are going to be proportional to EF and FG. Okay? And congruent parts of parallel lines, continuing that idea, if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. We'll look at some examples below. For instance, that one is basically saying that if I have parallel lines and I have these 2 transversals and these are congruent, then these are going to be congruent. Okay? That's just the congruent parts of parallel lines statement. So let's find x and y in this example, and that will be it for this lesson. Notice that these parallel lines are cut by a transversal, and it cuts them into congruent segments. If they're congruent, well then 3y plus 8 is equal to 5y minus 7. Subtract 3y, add 7, y equals 7.5. Now for the x, remember what we said before? If it split those into congruent segments, then these segments are also congruent. So we can solve x by saying 6x minus 5 equals 4x plus 3. Subtract 4x and add 5 to both sides. We get that, divide by 2, and x equals 4. Okay, a lot of different things to look into there. Hopefully they help you work on the assignment.